Picture two people walking past each other on a quiet street. One heading east, the other west. Nothing special about this scene at all. Now picture that same moment, except consider what is happening 2.5 million light-years away in the Andromeda Galaxy. According to our best understanding of physics, these two people, passing each other on a sidewalk, moving at nothing more than walking speed, could disagree about what is happening right now in Andromeda by several days. Not what they can see, not what they can measure, but what they would call now. Several days of disagreement just by walking in opposite directions. This sounds absurd, like a mistake or a trick or a misunderstanding of something basic about time. But it isn't any of those things. Special relativity tells us exactly this, and it has been tested to extraordinary precision for over a century. That's what this video is about. We're going to explore one of the strangest and most unsettling ideas in all of physics, the possibility that the future already exists, that your tomorrow is as real as your yesterday, and that the passage of time itself might be something very different from what you've always assumed. This is the block universe, and some physicists and philosophers call it Eternalism. If it's an accurate picture of reality, then the way you experience time, that sense of the present moment flowing forward into an open future, is not quite what it seems. I'll be clear from the start. This is one of those topics where the physics is solid and well tested, but the philosophical conclusions remain debated. And I'll distinguish between what the equations tell us with confidence and what remains interpretation. The goal isn't to convince you that one view is correct, but to show you why serious physicists take these ideas seriously, and what it would mean if they're true. If you enjoy this kind of deep exploration, if you appreciate taking the time to really sit with ideas that challenge how you understand reality, consider subscribing to the channel, since it helps these explorations reach more curious minds and tells me this is the kind of content you want to see more of. Now, let's begin. Before we can understand why physicists talk about time in such strange ways, we need to understand what time meant before Einstein came along, what everyone assumed was obvious, and why his work shattered that assumption. For most of human history, time seemed like the simplest thing in the world, flowing from past to future, the present moment real and happening now, the future not yet here. These weren't even ideas that needed stating, since they were so obvious they barely qualified as beliefs. Isaac Newton's Principia in 1687 formalized the laws of motion and gravity with these intuitions built into the foundations, treating time as absolute and flowing uniformly everywhere at the same rate for everyone. If it's 3 p.m. here, it's 3 p.m. everywhere, since present moment is universal. And this matched our everyday experience completely. You and I might disagree about many things, but we wouldn't disagree about whether something is happening now, or in the past, or in the future, since those categories seemed as real and fixed as the objects around us. For over 2 centuries, this served as the bedrock of physics. Time was time. Simple, universal, absolute. That changed in 1905. Albert Einstein, 26 years old and working as a patent clerk in Switzerland, published a paper that would eventually transform how we understand reality itself. introducing what we now call special relativity, with a revelation buried within its mathematics that challenges everything we think we know about time. The core of Einstein's insight came from thinking carefully about one simple fact. The speed of light in a vacuum is always the same, regardless of how fast you're moving or how fast the light source is moving. 299,792,458 meters per second, or about 670,616,629 miles per hour, never varying. This might not sound revolutionary, but think about what it means. Standing still with a flashlight, the light travels away from you at 299,792,458 meters per second, which makes sense. Now picture yourself on a spaceship traveling at half the speed of light, turning on the same flashlight, pointing in the direction you're traveling. Common sense says the light should now be traveling at 1.5 times the speed of light relative to a stationary observer. Your speed plus the light's speed. That's not what happens, though. The light still travels at exactly the speed of light, not 1.5 times, just the speed of light, same as before. This violates everything our intuitions tell us about how speeds should add. And when Einstein worked through the mathematics of what this constant speed of light really means, he discovered something that shattered the Newtonian picture of time. Simultaneity is relative. Let me explain what that means, because it's the key to everything that follows. Simultaneous seems simple in our everyday experience, with two events happening at the same time being simultaneous. End of story. Einstein's equations showed this isn't quite right, though, because two events that appear simultaneous to one observer may not appear simultaneous to another observer moving relative to the first. The mathematics is precise about this, with a formula called the Lorentz transformation, describing exactly how observers in relative motion will disagree about when events happen. For two events separated by some distance, the difference in how two observers assign times to those events is approximately equal to their relative velocity multiplied by the distance between the events divided by the speed of light squared. This formula has been tested countless times and forms the basis of particle physics, GPS satellites, and countless technologies. The mathematics works, and the question isn't whether it's correct, but what it means. That's where things get strange. Picture two observers moving past each other at a modest speed. Nothing dramatic, just one person walking east and one walking west, with their relative speed about 1 meter per second, around 2.2 miles per hour. Across ordinary distances, the difference in their simultaneity assignments is negligible, with agreement to within a tiny fraction of a nanosecond, if they're trying to determine what's happening now on the other side of the room. We never notice this in daily life, because the effect is far too small to detect. The formula says the disagreement grows with distance, though, with the farther apart the events, the larger the disagreement. Let's take this to an extreme. 2.5 million light-years separates us from the Andromeda Galaxy, which translates to approximately 2.365 times 10 to the 22nd power meters, or roughly 1.47 times 10 to the 19th power miles. Now consider our two observers, walking past each other at 1 meter per second in opposite directions. When they look toward Andromeda and ask what is happening there right now, the mathematics of special relativity says they will disagree. Not by nanoseconds, not by minutes, but by approximately 3.05 days. If one of them says, right now in Andromeda it's Tuesday, the other one, because of nothing more than their slow relative motion, would say, right now in Andromeda it's Friday. Here's the uncomfortable part. Neither of them is wrong. According to special relativity, there is no fact of the matter about which one is correct. And simultaneity at great distances is not an objective feature of reality, but depends entirely on your motion. This result is sometimes called the Andromeda paradox, popularized as a vivid illustration of what relativity of simultaneity really means when you take it seriously. Pause for a moment and really try to absorb this. Two people walking slowly past each other, disagreeing by multiple days about what is happening now in another galaxy, with neither of them making a mistake because the disagreement is built into the structure of space-time itself. I remember the first time I truly understood this, and I had to put down the book and just sit with it for a while. If this is true, if simultaneity really is relative in this way, then the present moment is not what we think it is, and the now is not carved into the fabric of reality, but is perspective-dependent, like the direction you call forward or to the right. That has consequences. Now let's talk about what this means for the nature of time itself. 1908 brought a mathematician named Hermann Minkowski, taking Einstein's equations and reframing them in a new way, just 3 years after Special Relativity's publication. Minkowski demonstrated that space and time, which we usually think of as separate things, can be combined into a single 4-dimensional structure called space-time. In this picture, the universe is not 3-dimensional space that changes over time, but rather 4-dimensional space-time, with what we call time simply one of the dimensions, no more special than the dimensions of space. An event in your life is not something that happens and then vanishes into the past, but rather a point in space-time with specific coordinates. And that point is just as real as any other point. Your birth sits at one set of coordinates, your reading of this sentence at another, and both of those points exist within the 4-dimensional structure. When Minkowski introduced this framework, he made a striking statement about it. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Space and time as separate concepts are shadows, and the real thing is the unified structure, space-time. In this 4-dimensional picture, your entire life is a world line, a thread that traces through space-time from your birth coordinates to your death coordinates, with every moment of your existence located somewhere along that thread. The thread doesn't move through space-time, but simply exists within it. This way of thinking about reality is called the block universe, or Eternalism, and all of space-time exists together like a block. Past events are not gone, while future events are not non-existent, since they're all there at their respective locations in the block. What we experience as the passage of time in this view is something like moving through a landscape, with the landscape not changing while you simply find yourself at different points in it. Different points along your world line correspond to different conscious experiences, and you experience those in sequence. But the sequence exists all at once within the four-dimensional structure. This is a radical idea, and many people find it deeply counterintuitive. But here's why physicists take it seriously. The relativity of simultaneity seems to push us toward it. The argument was made explicit by philosopher C.W. Reitdijk in 1966 and Hilary Putnam in 1967. And it starts with a simple question. What exists right now? If you're a presentist, you believe that only the present moment exists, with the past having ceased to exist and the future not existing yet. Reality becomes a kind of moving spotlight, illuminating only the present, while everything else sits in darkness. This is how most people naturally think about time. The past is gone, the future hasn't happened, only now is real. Think about what the relativity of simultaneity means for this view, though. Picture an event happening in Andromeda. Call it Event A. Right now, as you sit here, there exists some observer moving relative to you, for whom Event A is in their past, already happened and done. According to their frame of reference, Event A is a settled fact, no longer subject to change. From your perspective, though, Event A might be in your future, not having happened yet from your point of view. The key question is whether Event A is real. If you're a presentist, believing only the present exists, you might say Event A isn't real for you because it's in your future. Another observer, though, equally valid according to the laws of physics, says Event A is real because it's in their past. The Reitdijk-Putnam argument holds that both observers must be describing the same reality, since there's only one universe after all. If Event A is real, according to one observer, and that observer is just as legitimate as you, then Event A is real, period. The argument continues, if any event that is past for some legitimate observer is real, and if there are legitimate observers for whom almost any distant event is in the past, then distant events are real, regardless of whether they're in our past, present, or future. The relativity of simultaneity seems to force us toward eternalism. And if you can't draw an objective line between now and not now, then the distinction may not correspond to a difference in what exists. I want to be careful here because this argument has been debated by philosophers for decades and is not universally accepted. There are sophisticated responses and critiques, and 2021 brought Yaron Sheffer publishing a detailed critical analysis of the Andromeda paradox, arguing that the usual metaphysical takeaway is not straightforward. The physics is settled, though. The relativity of simultaneity is real. The equations work. And what remains contested is whether this forces us to accept the block universe interpretation. Many physicists, when they think about the implications of relativity, find themselves drawn to the block universe view. because the mathematics seems to suggest that space-time is a unified whole with no objective present carved into it. Einstein himself seemed sympathetic to this view. March of 1955, shortly before his own death, brought Einstein writing a letter to the family of his close friend Michel Besso, who had recently died. In that letter, Einstein offered comfort with a striking statement. He wrote that for those who believe in physics, the distinction between past, present and future is only a stubbornly persistent illusion. An illusion, that's the word Einstein used. Not wrong exactly, but not capturing something objectively real about the world either. Think about what it would mean for the distinction between past, present and future to be an illusion. Right now, you're experiencing this moment, and it feels utterly real, utterly present, utterly now. The moments you remember from yesterday feel like the past, gone, no longer real, while the moments you'll experience tomorrow feel like the future, not yet real, open, undetermined. Einstein's suggestion is that this feeling, this sense of temporal flow, is like an illusion, not in the sense that it isn't happening, but in the sense that it doesn't reflect the objective structure of reality. Compare it to the illusion of the solid ground beneath you. The floor feels solid, but physics tells us it's mostly empty space with atoms held apart by electromagnetic forces. And the solidity isn't exactly false, but isn't what's fundamentally there either. The flow of time might work the same way. Not exactly false, but not what's fundamentally there. If the block universe is accurate, then what's fundamentally there is a four-dimensional structure containing all events, past, present, and future. Your life is a thread through this structure, and your experience of now is something that happens at each point along the thread. But the thread exists all at once within the block. This is the part that still amazes me, even after years of thinking about this topic, the idea that yesterday and tomorrow are both there, that they both exist in the same sense that today exists, that the difference between them is somehow analogous to the difference between here and there, rather than the difference between real and not real. Let me give you another way to think about this. Picture a novel that exists as a book, with all the pages there at once. Chapter 1 exists, Chapter 10 exists, the ending exists, all equally real as parts of the book. Within the story, the characters experience events in sequence, and for them, there's a flow from earlier to later, with the events of Chapter 1 feeling like they happen before the events of Chapter 10. From outside the story, though, from the perspective of someone holding the book, there's no flow. All the chapters simply are, and the beginning and the ending are equally present, equally real, equally part of the book's existence. If the block universe is correct, reality is something like a story that exists all at once. We experience it in sequence, moving through it page by page, but the whole thing is there, and past, present and future are like earlier and later chapters, all equally part of the book of space-time. This analogy isn't perfect, since in a novel, the story is told from outside, while in reality, we're characters within the story, with no access to an outside perspective. The analogy captures something valuable, though: the difference between how something is experienced from within and how it exists as a whole. Let me invite you to really think about what this would mean for your own life. If the block universe is correct, then the you of yesterday still exists somewhere in space-time at the coordinates of yesterday. Not gone, but just at a different location in the four-dimensional structure. The you of tomorrow already exists at the coordinates of tomorrow, not yet real, but just at a location you haven't experienced from yet. Every moment of your life is somewhere in space-time. Birth, death, and everything in between, all of it there, part of the structure. For some people, this is deeply disturbing, seeming to imply that the future is fixed, that free will is an illusion, that everything is predetermined. For others, there's something comforting about it. Everything that has happened is still there in some sense. Everyone who has died still exists at the coordinates of their life, and the past isn't lost. For still others, both reactions seem like misunderstandings, since the block universe doesn't necessarily imply determinism in the sense people usually mean, and doesn't make the past recoverable in any practical sense. We'll explore some of these implications later, but for now, sit with the idea, since this is one of those concepts that rewards patient attention. Now let's go deeper, because special relativity, as strange as it is, was just the beginning. 1915 brought Einstein completing his masterwork, general relativity. This theory extends special relativity to include gravity and makes the picture of space-time even more interesting. In general relativity, space-time is not just a fixed four-dimensional stage on which events happen, but rather something dynamic that curves and bends in response to the presence of mass and energy. What we experience as gravity is actually the curvature of space-time itself. This has deep implications for the block universe picture. In special relativity, even though different observers disagree about simultaneity, you can still imagine slicing space-time into flat surfaces of now, one for each observer. Different observers would slice it differently, but the slicing remains possible. General relativity makes this much more complicated, and many spacetimes that are solutions to Einstein's equations don't admit any natural global slicing into space at a time. There's no way to extend a present moment across the entire universe in a well-defined way. Some special spacetimes used in cosmology do allow convenient time coordinates. Our standard cosmological model uses a time coordinate that corresponds roughly to the age of the universe since the Big Bang. This is a model-dependent structure, though, a choice we make for convenience rather than something carved into the fundamental physics. The mathematics of general relativity suggests that space-time is the fundamental reality, and any division into space and time is something we impose rather than something inherent in the structure. This reinforces the block universe view. If space-time is the fundamental thing, and if slicing it into moments of now is arbitrary and observer-dependent, then the four-dimensional whole seems to be what's real, and the three-dimensional present is just a way we look at it. Let me help you visualize what this four-dimensional structure looks like. We're used to thinking in three dimensions: length, width, height. We can picture a cube or a sphere or any three-dimensional object. Adding a fourth dimension challenges our spatial intuition. Here's a way to think about it, though. Picture taking a movie of something simple, like a ball bouncing. Each frame shows the ball at a particular position. And now picture stacking all those frames on top of each other, with time running upward. What you get is a kind of tube or trail, showing all the positions the ball occupied throughout the movie. That tube is the ball's world line, the complete four-dimensional history of the ball from the beginning of the movie to the end. In the block universe, everything has a world line like this. Every particle, every object, every person. Your world line begins at your birth and ends at your death, and every moment in between is a point along that world line. Now, picture doing this for everything in the universe. Every object's world line is there, tracing through space-time, curving toward each other when there's gravity, intersecting when objects meet, branching when objects split apart. The result is a vast, intricate, four-dimensional structure containing everything that has ever happened and everything that ever will happen. Past, present, and future, all woven together in the fabric of space-time. This is the block universe. There's something I want to address directly because it's often the first objection people raise. Doesn't this mean the future is determined? Doesn't this mean we have no free will? This is a deep question, and philosophers disagree about the answer. Let me offer a perspective that might help. The block universe doesn't necessarily tell us anything new about determinism or free will. And here's why. Suppose you make a decision tomorrow, choosing to have coffee instead of tea. In the block universe view, that decision exists at a particular location in space-time. The fact that it already exists in the four-dimensional structure doesn't mean it was forced on you, but just means that your decision, whatever it is part of the structure. The block universe is just a description of what happens and doesn't tell us why things happen or whether they had to happen that way. Those are separate questions. Compare it to a map. A map of your city shows all the roads and buildings, and if you drive from your house to the grocery store, the route you take exists on the map. But the map didn't make you take that route. The map just shows what's there. The block universe shows what happens in space-time the same way. It doesn't tell us whether what happens was inevitable or whether it could have been different. And those questions require additional philosophical work. Some physicists and philosophers do think the block universe supports determinism, arguing that if the future already exists, it seems like it must be fixed. Others point out that this conflates two different questions. Does the future exist? And is the future determined? These might be separate issues. I don't want to pretend this debate is resolved, because it isn't. But I also don't want you to think that accepting the block universe automatically means accepting that your choices don't matter. That's a further claim, requiring separate argument. Let me share some numbers that might help you feel the scale of what we're talking about. Light travels at 299,792,458 meters per second, about 670,616,629 miles per hour, or about 1,079,252,8 849 kilometers per hour. In 1 year, light travels approximately 9.46 trillion kilometers, or about 5.88 trillion miles. And that distance is called a light year. 2.5 million light years separates us from the Andromeda Galaxy. And let me help you feel what that distance means. Converting the distance to Andromeda into meters gives approximately 2.365 times 10 to the 22nd power meters, a 2 followed by 22 zeros. In miles, it's approximately 1.47 times 10 to the 19th power miles, a 1 followed by 19 zeros. These numbers are almost impossible to grasp, but here's what they mean for the Andromeda paradox we discussed earlier. When two people walk past each other at about 1 meter per second in opposite directions, the difference in their simultaneity assignments for events in Andromeda is about 3.05 days. Walking at a brisk pace of about 1.4 meters per second grows the difference to about 4.26 days. Just by walking, not by traveling in a rocket, not by approaching the speed of light, just walking at everyday human speeds. The reason the effect is so large is because of that vast distance. The formula for the simultaneity shift depends on both the relative velocity and the distance to the events in question. And across the room, the effect is immeasurably tiny. Across Earth's diameter, about 12,742 kilometers, with a relative speed of 1 meter per second, the shift is only about 0.142 nanoseconds, which is why we never notice this in daily life. Across 2.5 million light years, though, even tiny relative velocities translate into days of disagreement about now. Think about what that means for any hope of an objective present moment. If you and I can disagree about what's happening now in Andromeda by multiple days based on nothing more than our walking speeds, then now in Andromeda is not an objective feature of reality. It depends on motion, and it's relative. If now in Andromeda isn't objective, what about now in the next room? In principle, the same effect applies, just too small to measure. The lesson is the same, though. Simultaneity is not built into the fabric of space-time, but is something that observers construct, and different observers construct it differently. This is one of the deepest lessons of special relativity, and it took decades for its implications to be fully appreciated. Let me shift our attention to something closer to home: your experience of time. Whatever the physics says about space-time, you experience time as flowing, with the present moment feeling real and vivid, the past feeling gone and accessible only through memory, the future feeling open and undetermined and not yet there. This experience is universal among humans, and we all feel time passing. All experience the now as special. All feel like the future is something we're moving toward. Where does this experience come from? Philosophers call our experience of the present moment the specious present, the brief window of time that feels like now to us. Psychological research suggests this window runs about 2 to 3 seconds long. And within this window, events feel simultaneous and present, while outside it, events feel like the past or anticipated future. Why do we have this experience, though? And why does it feel like time flows? Modern neuroscience suggests that our experience of time is constructed by our brains. We don't perceive time directly the way we perceive light or sound, but instead piece together a sense of time from memory, prediction, and neural dynamics. Research has identified time cells in the hippocampus and entorhinal cortex that seem to track the passage of time. These neurons fire in sequence, creating a kind of internal clock that helps us situate events in time and distinguish past from future. Here's the key point, though. All of this happens inside our brains. Our experience of temporal flow is something our nervous system constructs, a feature of how conscious experience works rather than necessarily a feature of external reality. In the block universe picture, this makes sense. If all of space-time exists together, then what we call the flow of time is something that happens within conscious minds, situated at particular points along their world lines. Each conscious moment has the experience of being now, with memories of the past and expectations about the future. But objectively, from outside the world line, there is no flow. The world line just is. This is a strange idea. It suggests that one of the most basic features of our experience, the feeling that time passes, might not correspond to anything in the physical world. The passage of time might be like the apparent motion of the sun across the sky, real as an experience, but not reflecting what's actually happening. If time doesn't really pass, why do we experience it as passing? This is a deep and difficult question. One answer, compatible with the block universe, is that each moment of consciousness along your world line includes experiences that feel like flow. Each moment includes memories of the immediately preceding moments, creating a sense of continuity. And each moment includes anticipation of what comes next, creating a sense of moving forward. You don't need time to actually flow for this to work. You just need each moment to contain the appropriate mental states, the memories, the anticipations, the sense of this is now. And if those mental states are present at each point along your world line, then you'll experience flow at each point, even if the world line as a whole is static. It's like how each frame of a movie contains the appearance of motion, even though the frames themselves are static images. The motion isn't in any single frame, but emerges from the relationship between frames. The sense of temporal flow might work the same way, not existing in any single moment, but emerging from the relationships between conscious states along the world line. This is speculative, of course, and we don't fully understand consciousness, or how it relates to the structure of space-time. The block universe provides a framework for thinking about these questions, though, one that many find illuminating. There's another aspect of time we need to address: the arrow of time. Even if the block universe is correct, and all of space-time exists together, there's still something special about the direction we call future. We remember the past, not the future, can affect the future, but not the past. And cause comes before effect rather than after. Where does this asymmetry come from? The fundamental laws of physics, as we understand them, are largely time-symmetric. Run them forward or backward and they work equally well. If you film a simple physical process and then play the film in reverse, the reversed version is just as physically valid as the original. Why does time seem to have a direction then? The answer that physicists usually give involves thermodynamics and a concept called entropy. Entropy is, roughly speaking, a measure of disorder or randomness. A neat, ordered state has low entropy, while a messy, disordered state has high entropy. The second law of thermodynamics says that in an isolated system, entropy tends to increase over time. This gives time a direction. The future is the direction in which entropy increases, and the past is the direction in which entropy was lower. Here's the deep puzzle, though. Why was entropy low in the past? The fundamental laws of physics don't explain this, since they're time-symmetric and don't prefer low entropy in the past any more than in the future. The standard answer is what physicists call the past hypothesis, the assumption that the early universe near the Big Bang was in an extraordinarily low entropy state. From that starting point, entropy has been increasing ever since, giving us our arrow of time. Recent work from 2024 has connected this to quantum mechanics and a concept called decoherence, the process by which quantum superpositions become classical-looking states. Some researchers have argued that the arrow of time emerges from the interplay between the past hypothesis and the dynamics of entanglement and decoherence at the quantum level. What does this mean for the block universe? It means that even within the block, there's a direction. Not because the block is incomplete on one end, but because the pattern of events within the block is asymmetric. One direction has lower entropy than the other. Memories and records point in that direction, and causation works in that direction. The block universe doesn't deny that time has an arrow. It just says that the arrow is a feature of the pattern of events within the block, rather than evidence that the future doesn't exist or that time literally flows. Think of it like a painting of a landscape. The painting might show a river flowing from mountains to the sea, and within the painting, a direction of flow with water going from higher to lower. The painting itself is static, though, and the flow is a pattern in a static image. The arrow of time in the block universe works the same way, a pattern in a static four-dimensional structure. The pattern is real, the asymmetry is real, but it doesn't require time to actually flow. Let me walk through the history of how these ideas developed, because I think the evolution of understanding is as fascinating as the ideas themselves. Before Einstein, time was simple. Newton's physics treated time as absolute and universal, with everyone agreeing on what now meant. Time was a dimension, but it was special, different from the three dimensions of space. Philosophers debated whether the past and future existed, but this was metaphysics rather than physics, since the physical laws didn't have anything to say about it. 1905 brought special relativity, with Einstein showing that time is not absolute. Different observers in relative motion disagree about simultaneity, and the now is not universal. This was revolutionary, but the full implications took time to sink in. 1908 brought Minkowski, providing the mathematical framework of four-dimensional spacetime, making clear that space and time are unified and that events are points in a four-dimensional structure. Minkowski didn't fully explore the philosophical implications for the nature of time, though. 1915 brought general relativity, extending the picture to include gravity and curved spacetime. The mathematics became more complex, but the basic lesson was reinforced. Spacetime is the fundamental reality. It wasn't until the 1960s that philosophers began to seriously work out what relativity implies about the existence of past and future. 1966 brought C.W. Reitdijk, publishing a paper titled A Rigorous Proof of Determinism Derived from the Special Theory of Relativity, in the journal Philosophy of Science. Reitdijk argued that special relativity implies that events we call future are just as real as events we call past, because for some other observer, they're already in the past. 1967 brought Hilary Putnam publishing Time and Physical Geometry in the Journal of Philosophy, developing a similar argument. Putnam argued that special relativity creates strong pressure against presentism, the view that only the present exists. These papers sparked decades of philosophical debate. Some philosophers accepted the arguments and embraced the block universe, while others found ways to resist, arguing that relativity doesn't force the metaphysical conclusions Reitdijk and Putnam drew. The debate continues to this day. 2021 brought Yaron Sheffer publishing a paper in the research notes of the American Astronomical Society, offering a critical analysis of the Andromeda paradox, arguing that the usual metaphysical takeaway is not as straightforward as often presented. The physics of special relativity is not in dispute. The equations work, and relativity of simultaneity is real. Whether this forces us to accept the block universe interpretation remains a matter of philosophical debate, though. What I can tell you is that many physicists, when they think carefully about relativity, find themselves drawn towards some version of the block universe view. The mathematics seems to suggest that space-time is a unified whole, and the distinction between past, present, and future is not carved into the equations. Physics alone may not be able to settle the metaphysical question, though. What exists is a philosophical question, and the answer may depend on arguments that go beyond what the physics equations can tell us. Now let's explore some of the implications of the block universe, if it's correct. One implication is about identity and persistence. In our everyday thinking, we assume that the you of yesterday and the you of today are the same person, that you persist through time. What does this mean in a block universe, though? In the block universe, there isn't really a you that moves through time. Instead, there's a world line, a four-dimensional thread through space-time containing all the momentary stages of your existence. Each stage is connected to the next by physical and psychological continuity, but no stage is moving to the next. What makes these different stages the same person is not that they share some continuing substance that moves through time. It's that they're appropriately connected to each other through causation, memory, and physical continuity. This might sound abstract, but it has concrete implications for how we might think about personal survival and death. In the presentist picture, when you die, you cease to exist, the you that was there is no longer there, and the present moment marches on without you. In the block universe picture, death works differently. The world line has an end point, a last moment. But that moment doesn't disappear. It's there at its coordinates in space-time. And the you at your death exists in the same sense that the you at your birth exists. Both are part of the block. Does this mean you're immortal? No, not in any practical sense. Your world line is finite, with only so many moments along it, and after the last moment, there are no more. It might mean that existence is more permanent than we usually think, though. The moments of your life are not lost when they pass, but remain in the four-dimensional structure forever. Einstein seemed to find some comfort in this view. Remember his letter to the Specious family, where he said the distinction between past, present, and future is a persistent illusion. He wrote that letter to comfort them after Specious' death, suggesting that in some sense Specious' existence was not ended but remained part of the structure of space-time. Whether you find this comforting or disturbing probably depends on your temperament. Some people find the permanence reassuring, with every moment lived and every experience had preserved in the block. Others find the lack of genuine flow distressing, wondering what's the point if everything already exists and what there is to strive for. These are deep questions, and I don't think physics can answer them. The block universe, if true, tells us something about the structure of reality. But what it means for our lives is something we each have to work out for ourselves. Let me bring this back to human scale for a moment, because I think it's easy to lose sight of how extraordinary all of this is. You woke up this morning, probably had breakfast, and are watching or listening to this right now. These all seem like ordinary experiences, happening in ordinary time, one after another. According to what we've discussed, though, each of those moments is a point in a four-dimensional structure, each existing at specific coordinates in space-time, and each as real as any other. The you who woke up this morning is there at those coordinates, having that experience. The you reading this is here at these coordinates, having this experience. Neither is more real than the other, and both exist. The sense that this moment is special, that it's now, that it's the one real moment, that sense is happening at every point along your world line. Every moment feels like now from within. When I first really grasped this, I had to sit with it for a long time. It changes how you relate to time. Not necessarily in a practical way, since you still plan for the future and remember the past, but in an existential way. The texture of experience feels different when you think about it this way. Let me explore something that might seem like an objection to the block universe. Quantum mechanics. Quantum mechanics is the physics of the very small, of atoms and particles and photons, and it's famous for involving randomness and uncertainty. Particles don't have definite properties until they're measured, and outcomes are probabilistic rather than deterministic. Some people think quantum mechanics might rescue presentism and the open future. If the future is genuinely random and genuinely not determined, then it might not exist yet. Quantum mechanics might show that the block universe is incomplete. This is a complex topic, and physicists disagree about it. Let me share what I think is a fair summary. Quantum mechanics does introduce something that looks like fundamental randomness. When you measure a quantum system, you get one of several possible outcomes, with probabilities determined by the system's state. And no one can predict with certainty which outcome will occur. Here's the thing, though. This doesn't obviously contradict the block universe. The block universe just says that whatever happens is part of the four-dimensional structure. And it doesn't say that what happens is predictable or determined in advance. In the block universe, the quantum measurement and its outcome both exist at their space-time coordinates. The outcome exists, but that doesn't mean it was predictable before it happened. Think of it this way. Picture flipping a coin with the outcome, heads or tails, being random. You can't predict it, but once it happens, it has happened and is part of history. In the block universe, the future works the same way. Quantum randomness might mean we can't predict what's in the future, but that doesn't mean the future doesn't exist. It just means we don't know what it is until we get there. This is subtle, and not everyone agrees with this interpretation. Some interpretations of quantum mechanics, like the many worlds interpretation, are very compatible with the block universe. In many worlds, all possible quantum outcomes are real, each in its own branch of the wave function. And this is an extreme block universe where even more exists than in the standard picture. Other interpretations, like some versions of the Copenhagen interpretation, are less clearly compatible. They emphasize that quantum outcomes become definite only upon measurement, which might suggest that future measurements don't have definite outcomes yet. This is an active area of research and debate, and the relationship between quantum mechanics and the block universe is not fully worked out. I don't think quantum mechanics clearly refutes the block universe, though, because the picture is more complicated than that. Let me talk about something that might seem mundane, but is actually deeply connected to these ideas. Why do we remember the past and not the future? This is a strange question. Of course, we remember the past, since that's what memory is. In the block universe, though, past and future are both there. So, why should we have access to one direction and not the other? The answer connects to entropy and the arrow of time. Memories are physical records, patterns in your brain and states of neurons that correlate with past events. These patterns are formed by the causal influence of past events on your brain. For such records to form, you need a direction of increasing entropy. Records and memories are examples of low entropy correlations, ordered patterns that carry information about other events. And for such patterns to form, you need to start from a low entropy state. This is why memories point toward the past. The past is the direction of lower entropy, the direction from which the ordered state came, and records form in the direction of entropy increase. If entropy decreased toward the future, we would have records of the future instead. Our memories would be of events that from our current perspective haven't happened yet. This sounds bizarre, but physics doesn't forbid it. It's just that in our universe, the boundary conditions establish low entropy in the past rather than the future. This is why memory doesn't refute the block universe. Memory is not a perception of what exists versus what doesn't exist, but rather a physical process that creates correlations in one temporal direction rather than the other. And that direction is set by the thermodynamic arrow of time. In the block universe, both past and future exist. But our brains, as physical systems embedded in the block, form correlations primarily with the low entropy direction, which we call the past. This is one of those ideas that takes time to absorb. Our experience of time is so immediate, so fundamental, that it feels like it must be reflecting something basic about reality. The idea that memory is just a thermodynamic phenomenon, that our sense of the past is a consequence of entropy conditions rather than a window onto what truly exists, is deeply counterintuitive. Counterintuitive doesn't mean wrong, though. Many of the deepest insights in physics have been counterintuitive. The Earth moving around the Sun was counterintuitive, and quantum mechanics is counterintuitive. Sometimes reality is just different from what our everyday experience suggests. Let me talk about cosmology for a moment, because it adds another layer to this discussion. Our current cosmological model describes a universe that began in a hot, dense state about 13.8 billion years ago and has been expanding and cooling ever since. This is often called the Big Bang. In this model, time has a beginning. There was a first moment, or at least something approaching a first moment, and before that point, our current physics breaks down, and we don't know how to describe what was there. What does this mean for the block universe? If the universe has a temporal beginning, then the block is not infinite in the past direction. There's an edge to space-time, a boundary where things start. This might seem to conflict with the block universe picture, but it doesn't really. The block universe just says that space-time is a four-dimensional structure, and that all the events within it are equally real. It doesn't say the structure has to be infinite in all directions, and the block can have edges and boundaries. The standard cosmological model is naturally described in block universe terms. Cosmologists routinely describe space-time as a whole, from the Big Bang to the far future, drawing diagrams showing the entire history of the universe, past and future, as a single four-dimensional structure. Cosmology reinforces the block universe picture, if anything. The mathematics of general relativity, which underlies cosmology, naturally describes space-time as a unified entity. Cosmologists don't usually think of time as flowing, but rather think of space-time as existing. Cosmology also raises interesting questions, though. What about the far future? Does it exist yet? In the block universe view, yes. If the block includes all of space-time, then it includes not just the Big Bang and now and next year, but also events billions of years in the future. The eventual fate of the universe, whatever it turns out to be, is already part of the block. This might seem strange. How can events that won't happen for billions of years already exist? Remember, the block universe says that already and not yet are perspectival notions tied to a particular observer's world line. From within the block, at any given point, some events are in the past relative to that point, and some are in the future. The block as a whole just is, though, and doesn't have a now that divides it. The far future exists in the same sense that the far past exists. We just happen to be located at our particular position in the block, unable to directly perceive the distant parts. Let me address another common concern. If the future already exists, can we change it? This might seem like an obvious no. If the future is already there, fixed in the block, then we can't change it. This reasoning might be confused, though. Let me explain. In the block universe, the future is determined in the sense that it has a definite content. There are facts about what happens tomorrow, just as there are facts about what happened yesterday. This doesn't mean your choices don't matter, though. Your choices are part of the block. When you make a decision is an event in space-time, located at particular coordinates, and the decision causally influences later events. Your actions shape the future. The block universe doesn't say your choices are overridden by some external fate. It says your choices are part of the structure and are included in what happens. Think of it this way. Suppose you're deciding whether to have coffee or tea tomorrow morning. Whatever you decide, that decision will be part of the block. If you decide coffee, then the block contains you deciding coffee. If you decide tea, then the block contains you deciding tea. The block doesn't decide for you. You decide, and your decision is what makes the block be the way it is. This might seem like a subtle point, but it's important. The block universe is not fatalism. Fatalism says your choices don't matter, that things will happen regardless of what you do. The block universe says your choices matter enormously, since they're what determines the shape of the block. The difference between the block universe and everyday thinking is not about whether choices matter, but about the relationship between what you choose and what exists. In everyday thinking, your choices determine a future that doesn't exist yet. In the block universe, your choices are part of a structure that exists timelessly. In both pictures, though, choices are causally effective. Let me be fair and present some of the alternatives to the block universe. Not everyone who understands relativity accepts eternalism, and there are other views that try to preserve more of our intuitive picture of time while accommodating the physics. One alternative is called the growing block theory. In this view, the past and present exist, but the future does not. The block is not complete, but growing as time passes, and each moment new events come into existence and are added to the block. This preserves the sense that the future is open, that it genuinely doesn't exist yet, while still accepting that the past exists, and that past events are not simply gone. The growing block theory faces a challenge from relativity of simultaneity, though. If there's no objective now that divides what exists from what doesn't, then where does the edge of the block lie? Different observers would disagree about where the boundary is, which seems to imply that the boundary isn't objectively real. Defenders of the growing block have proposed various responses to this challenge. Some suggest that there's a privileged foliation of space-time, a particular slicing into moments that represents the true boundary of existence, even if observers can't detect it. Others have developed more sophisticated positions that try to accommodate relativistic effects. Another alternative is called presentism, the view that only the present exists. Past events have ceased to exist, and future events don't exist yet, with only the instantaneous present being real. Presentism matches our intuitive experience very well. well. The present feels special, the past feels gone, and the future feels open. Presentism has a harder time with relativity than the growing block does, though. If the present is all that exists, and if relativity shows that the present is observer-dependent, then what exists would be observer-dependent. Different observers in relative motion would have different presents, which would mean different realities. This seems problematic. Presentists have proposed various responses. Some accept that there's a privileged frame of reference that defines the true present, even if relativity doesn't reveal which frame it is. Others have tried to reformulate presentism in ways that avoid the problem. I want to be clear that these are live philosophical debates. The block universe is not the only option, and smart people disagree about these questions. The physics alone may not settle the metaphysics. What I can say is that the block universe is taken seriously by many physicists, precisely because it seems to fit most naturally with the mathematics of relativity. When you write down the equations of special and general relativity, they describe a four-dimensional space-time rather than a three-dimensional space evolving in time. The natural interpretation of the mathematics is that space-time is the fundamental reality. Interpretation is where philosophy enters, though, and physics equations can be interpreted in more than one way. The debate continues. Let me talk about something that often comes up in these discussions. What would it mean for the block universe to be true? I've already touched on some implications, but let me go deeper. If the block universe is true, then your entire life already exists. From your birth to your death, every moment is there in space-time. The choices you'll make, the experiences you'll have, the successes and failures and joys and sorrows, all of it part of the structure. This might make you feel like a character in a story that's already been written. And in a sense, that's true. You're a character who experiences the story from within, though, making choices that feel genuinely open and living through each moment as if it were newly happening. The interesting question is, which perspective is more fundamental? Is the outside view, where the whole block exists at once, the real picture, with the inside view being an illusion? Or are both perspectives equally valid, just different ways of relating to the same reality? I'm inclined to think both perspectives are real. The block exists as a whole, and that's a genuine fact about reality. But you also genuinely experience time from within, and that's not a mistake or a misperception. It's just what it's like to be a conscious being embedded in a particular location within the block. Compare it to spatial perspective. From where you're sitting, some things are in front of you and some are behind, and that's real since it's your actual perspective. There's also a view from nowhere, though, a description of where everything is without privileging any particular location. And that's also real. There might be both your temporal perspective, where some events are past and some future, and a view from nowhere, where the whole of space-time is laid out without privileging any moment. Both are real, just different ways of describing the same reality. Let me share some thoughts about how I've come to think about my own life in light of these ideas. When I think about past experiences, good and bad, I sometimes remind myself that in the block universe picture, those moments are still there. The joy of a wonderful day years ago isn't lost or gone, but exists at its space-time coordinates, as real as today. When I think about the future, I sometimes remind myself that, from a certain perspective, it's already there. The uncertainty I feel about what will happen is a feature of my perspective, rather than a feature of the structure of reality itself. When I think about mortality, about the fact that my world line has an endpoint somewhere in space-time, I try to remember that ending a world line is not the same as erasing it. The moments of life remain part of the block, even after the world line ends. I'm not sure these reflections change anything practically, since I still plan for the future, still cherish memories, still feel the passage of time moment by moment. There's something about the block universe perspective that I find clarifying, though. A reminder that our usual way of thinking about time, though natural and useful, is not the only way. Let me take you through some thought experiments that might help make these ideas more vivid. Picture stepping outside of space-time and looking at it from the outside. What would you see? You'd see a vast four-dimensional structure containing all the events of history. Galaxies forming and dissolving, stars burning and exploding, planets coalescing from dust, life arising and evolving, civilizations building and falling. Everywhere threading through this structure would be the world lines of individual objects and beings. Your own world line would be there, a thin thread connecting your birth to your death. You'd see your entire life laid out, every moment you've experienced and will experience, from the perspective of someone who can see the whole thing at once. From this outside perspective, there's no flow. The structure just is, and every event is equally present, equally real. The distinctions we make between past, present, and future are not visible from out here, since they're features of perspective rather than features of the structure. You can't actually step outside of space-time, of course. You're embedded in it, and your perspective is necessarily from within. The thought experiment might help you grasp what the block universe claims, though, that the external view, even if inaccessible, is a valid description of reality. Here's another thought experiment. Picture meeting someone from the far future. In the block universe, this person already exists. They're at their coordinates in space-time, living their life just as you're at yours. The fact that you can't currently interact with them doesn't mean they're not there, since they're just in a different part of the block. This is strange to think about. Someone who won't be born for centuries from your perspective is nevertheless there in the structure, as real as you are right now. Their experiences are happening at their location in space-time. They have a perspective on time just as you do, and they remember what for you is the far future as their past. If you could somehow meet this person, you might find their existence hard to process. They're from the future, but from their perspective, they're just from now. Their now and your now are both parts of the same structure. Let me give you some numbers that might help ground these abstractions. The visible universe spans about 93 billion light-years in diameter. That's the part we can, in principle, observe, given the age of the universe and the speed of light. And in meters, it's approximately 8.8 times 10 to the 26th power meters. The age of the universe sits at about 13.8 billion years, or about 4.35 times 10 to the 17th power seconds. These numbers describe the current extent of the observable universe in space and time. But in the block universe picture, the structure extends beyond what we can currently observe. The future of the universe, whatever it is part of the block. The parts of the universe beyond our current horizon, outside our observable range, are part of the block. The block contains everything. Every galaxy we can see and every galaxy we can't. Every moment from the Big Bang to the far future. All of it there in the four-dimensional structure. Let me return to the Andromeda paradox one more time, because I think it's such a striking illustration of what's at stake. The Andromeda Galaxy sits 2.5 million light-years away. Two people walk past each other on Earth with their relative speed at maybe 1 to 2 meters per second. Their disagreement about what's happening now in Andromeda amounts to multiple days. Think about what kinds of events might be at stake. An Andromedan war council deciding whether to invade another star system. An Andromedan scientist making a breakthrough discovery. An Andromedan couple getting married. For one observer on Earth, these events are in the past, settled, already happened. For another observer walking in the opposite direction, these events are in the future, not yet occurred. Which observer is right? According to special relativity, both are, or rather, the question doesn't have an objective answer. Now in Andromeda is not a fact of the matter, but is observer-dependent. If you're a presentist, believing only the present exists, you have a problem. What exists depends on how fast you're walking, and that seems strange. If you accept the block universe, the problem dissolves. All the events in Andromeda exist at their coordinates in space-time, and the question of which ones are now is just about which ones are simultaneous with you, which is observer-dependent. It doesn't affect what exists, though. This is why the Andromeda paradox is such a powerful illustration. It takes the abstract physics of relativity, of simultaneity, and shows with concrete numbers just how dramatic the disagreement can be. Days of difference from walking speed. Let me talk about something that might seem like a tangent, but is actually deeply connected: the nature of change. In our everyday experience, things change. The sun rises and sets, people grow older, buildings are constructed and demolished. Change seems fundamental to reality. What is change in the block universe, though? In the block universe, change is a pattern within the structure. At one set of coordinates, the sun is in one position, and at later coordinates, it's in a different position. This difference between the earlier and later states is what we call change. The structure itself doesn't change, though. It's a static, four-dimensional object, and change is within the block, rather than of the block. This might seem to contradict our experience. We experience change as happening, and experience the world as dynamic rather than static. Remember, though, our experience is from within the block. We're conscious beings at particular locations in space-time. And at each location, we have certain experiences, including experiences of things changing. The experience of change is real, but the experience is a pattern in a static structure, rather than evidence that the structure itself is changing. This is subtle and worth spending time with. The block universe doesn't deny that change happens, but reinterprets what change is. Change is difference across time, pattern within the block. What the block universe denies is that the block itself evolves or grows. Think about a painting of a river. In the painting, the river appears to flow, with brushstrokes suggesting motion, ripples, currents. An observer looking at the painting sees a river in motion. The painting itself is static, though, an object, a canvas with pigments that doesn't change. The flow of the river is a pattern in the static painting, rather than a change in the painting. The flow of time in the block universe works the same way. A pattern in the static, four-dimensional structure rather than a change in the structure. The pattern is real, and we experience it, but what's real is a static block containing the pattern, rather than a changing reality whose state is given by the present moment. Here's a question that often comes up. If the block universe is true, does anything happen? This might seem like a strange question. Of course things happen. You woke up this morning, the sun rose, people were born and died around the world. These are things happening. Happening might be a loaded word, though. It suggests process, becoming, unfolding, the world moving from one state to another. In the block universe, none of this is quite right. Events don't happen in the sense of coming into existence. They don't become real, but just are at their locations in space-time. Events are real, though. The birth of a child is a real event with real coordinates in space-time. The death of a star is a real event. Your reading of this sentence is a real event. These events exist in the four-dimensional structure. The right thing to say might be that events exist, but they don't happen if happen implies coming into being. They just are. This is a philosophical subtlety, and you might think it's just playing with words. I think it captures something valuable about what the block universe claims, though. The claim is not that nothing is real, but that what's real is a static structure rather than a dynamic process. Let me talk about how these ideas relate to age-old human questions about mortality and meaning. Humans have always wondered what happens after death, and every culture has stories about what lies beyond, about afterlives and rebirths and final ends. Block universe offers its own perspective on death. In this view, death is the end of a world line, the last moment in a finite thread through space-time. The thread doesn't vanish, though. The moments before death remain at their coordinates in the structure. This might be cold comfort. You can't return to those moments or relive them. They're there, but you're not accessing them. And your consciousness, whatever it is, doesn't persist beyond the end of the world line. Or does it? This is where things get philosophically murky. What is consciousness? How does it relate to the moments along a world line? If each moment is there in the structure, is the consciousness associated with each moment also there? These questions go beyond what physics can answer. They touch on the hard problem of consciousness, on the nature of subjective experience, on what it is to be a self persisting through time. Some people find the block universe picture comforting despite these uncertainties. Even if consciousness doesn't persist, the moments of life do. Your happiest days are there in space-time forever. Your worst days are there too, but they don't erase the good ones. Everything is preserved. Others find no comfort in this. What good is preservation if you can't experience it? What good is the eternal existence of past moments if the you that lived them is gone? I don't have answers to these questions, since they're among the deepest questions humans can ask. What I can say is that the block universe provides a framework for thinking about them, a context in which to pose the questions, even if not to answer them. Let me discuss something about human perception of time that I find fascinating. Our experience of time is not a simple, unmediated perception, but is constructed by our brains out of memory, anticipation, and the dynamics of neural processing. Researchers have identified what's called the specious present, the brief window of time, maybe 2 to 3 seconds, that feels like now to us. Within this window, events feel simultaneous and present, while outside it, events feel like past or future. This specious present is not the same as the physical present. The physical present, to the extent it exists, is an instant, a zero-duration point in time, while the specious present is an extended duration, a window of awareness. What this means is that even our experience of now is a construction. It's not a direct perception of some objective instant, but a synthesis performed by our brains, weaving together inputs that actually arrived at slightly different times into a unified sense of the present. Neuroscientists have found time cells in the hippocampus and entorhinal cortex that fire in sequence, tracking the passage of time. These neural structures seem to underpin our sense of duration and our ability to situate events in time. All of this happens inside our heads. The experience of temporal flow, the sense of present becoming past as new moments arise, is a feature of conscious experience rather than necessarily a feature of external reality. In the block universe, this makes sense. If all of space-time exists as a static structure, then the experience of flow must be generated from within conscious minds at particular locations along their world lines. The flow is real as an experience, but it doesn't reflect something objective about the external structure. This is strange to contemplate. The most basic feature of our conscious experience, the sense that time passes, might not correspond to anything out there in the world. It might be an artifact of how our brains process information. Strange doesn't mean false, though. Many aspects of reality are strange, and the block universe, for all its strangeness, offers a coherent picture of how physics and experience might fit together. Let me spend more time on some of the specific numbers and scales involved, because I think they help make these abstract ideas concrete. The speed of light is exactly 299,792,458 meters per second. Not an approximation, but the definition. Since 1983, the meter has been defined in terms of the speed of light. So, by definition, light travels at exactly this speed in vacuum. In other units, that's about 186,282 miles per second, or 983,571,056 feet per second. Light could circle the Earth about 7.5 times in a single second. In an hour, light travels about 1,079,252,849 kilometers, or about 670,616,629 miles. In a year, light travels about 9.46 trillion kilometers, or 5.88 trillion miles. And that distance is 1 light year. These numbers are important because they set the scale for everything in relativity. The effects of special relativity become noticeable when speeds approach a significant fraction of the speed of light, or when distances are large enough that light takes significant time to travel. Now consider the Andromeda Galaxy, 2.5 million light-years away. That's 2.5 million times 9.46 trillion kilometers, which comes out to about 2.365 times 10 to the 19th power kilometers, or 1.47 times 10 to the 19th power miles. To give you a sense of what these numbers mean, imagine traveling at the speed of light itself. At light speed, it would take you 2.5 million years to reach Andromeda. That's longer than our species has existed, since the earliest members of the genus Homo appeared only about 2 million years ago. The journey to Andromeda at light speed is longer than the entire history of humanity. Even at these cosmic scales, the relativity of simultaneity produces dramatic effects. Two observers walking past each other, differing in velocity by just 1 meter per second, about 2.2 miles per hour, would disagree about what's happening now in Andromeda by about 3.05 days. Let me unpack that calculation. The formula for simultaneity, difference, is approximately v times delta x divided by c squared. With v equal to 1 meter per second, delta x equal to 2.365 times 10 to the 22nd power meters, the distance to Andromeda in meters, and c equal to 299,792,458 meters per second, you get delta t equals approximately 263,000 seconds, or roughly 3.05 days. If the observers are walking a bit faster, at 1.4 meters per second, about 3.1 miles per hour, the disagreement grows to about 4.26 days. These numbers are precise applications of the Lorentz transformation. They're not approximations or hand-waving, but what the physics actually says. Now, contrast this with what happens at more familiar scales. Across Earth diameter, about 12,742 kilometers or 7,917 miles, the same 1 meter per second relative velocity produces a simultaneity disagreement of only about 0.142 nanoseconds. A nanosecond is a billionth of a second, and this is far too small to detect in everyday life. This is why we never notice the relativity of simultaneity in our daily experience. At the scales of rooms and buildings and cities and even continents, the effect is negligible. It's only across cosmic distances that it becomes significant. The significance is the same physics, though, the same equations, the same Lorentz transformation. The effect scales with distance, and what's imperceptible in a room becomes days of disagreement across intergalactic space. Let me discuss a few more thought experiments. Picture making a perfect copy of yourself, atom for atom. This copy would have all your memories, all your personality, all your intentions. It would feel like you from the inside. Now, picture this copy being created from the block universe perspective, where all of space-time exists. There's the original you, whose world line extends from birth to death. And there's the copy, whose world line begins at the moment of copying. Are these two beings the same person? From each one's perspective, they feel like themselves. They're at different locations in space-time, though, and will have different futures. Their world lines diverge after the copying. This thought experiment raises questions about personal identity. What makes you, you, from one moment to the next? Is it continuity of body? Continuity of memory? Continuity of consciousness? In the block universe, each moment along your world line is a distinct event at its own coordinates in space-time. What makes all these events part of your life is that they're connected causally and psychologically. The connection is within the block, though, rather than something that persists through a flowing time. Here's another thought experiment. Picture two observers, Alice and Bob, moving relative to each other and each describing the Andromeda Galaxy. Alice says, "Right now in Andromeda, it's March 15, 2025, Andromeda time." Bob, moving past Alice at walking speed in a different direction, says, "Right now in Andromeda, it's March 20, 2025, Andromeda time." They're both using the phrase "right now," but they mean different things by it. For Alice, "right now" picks out a different set of events than it does for Bob. Neither is wrong. According to special relativity, there's no fact of the matter about which set of events is really simultaneous with their meeting. Simultaneity is relative. If Alice is a presentist, believing that only the present exists, she must believe that the events of March 15 in Andromeda are the ones that exist, while the events of March 20 don't exist yet. Bob, also a presentist, would believe that the events of March 20 are the ones that exist. They can't both be right if presentism is true. Yet, they're both equally good observers, following the laws of physics correctly. This is the core of the Reed-Dyke-Putnam argument. The relativity of simultaneity seems to imply that what exists cannot be observer-dependent. If it's the same reality, and both Alice and Bob are describing it, then both sets of events must exist. As I've said, this argument is contested with various responses. The pressure it puts on presentism is real, though, which is why so many physicists and philosophers have been drawn toward the block universe. Let me also address a question that often comes up. If the block universe is true, why does physics seem to involve laws that operate in time? This is a good question. The laws of physics, like Newton's laws or Schrödinger's equation, are typically written as differential equations that describe how things change over time. They seem to presuppose that time is something that flows, that systems evolve from one state to the next. This appearance might be misleading, though. The laws of physics can also be understood as constraints on the four-dimensional structure of space-time. Instead of saying, "This is how things evolve," they say, "This is the pattern that must hold across the structure." Consider a simple example. Newton's first law says that an object in motion stays in motion unless acted upon by a force. In the flowing time picture, this means the object keeps moving moment after moment. In the block universe picture, it means the object's world line is a straight line through space-time, as long as no force acts. The law is a constraint on the shape of world lines, rather than a description of evolution. This block interpretation of physical laws is mathematically equivalent to the flowing interpretation. The equations are the same, and the predictions are the same. The conceptual picture is different, though. Many physicists find the block interpretation more natural, especially in general relativity, where the equations directly describe the geometry of space-time as a whole. The initial value problem, where you specify the state at one time and compute the state at later times, is just one way of using the equations. You can also think of them as describing the entire four-dimensional solution at once. This is why the block universe isn't in conflict with physics having laws. The laws are part of what determines the structure of the block and constrain what patterns can exist. They don't require time to flow in any literal sense, though. Let me return to the historical development of these ideas, because I think there's something instructive in how they emerged. Newton's physics, with its absolute time, was the culmination of centuries of scientific progress. It provided a framework that worked spectacularly well for describing motion and gravity, and for over 200 years it was the foundation of physics. Einstein then questioned assumptions that seemed unquestionable, working in a patent office as a young man. He took the constancy of the speed of light seriously and worked out the consequences. The result was a new picture of space and time that overthrew Newtonian assumptions. This is a pattern we see throughout the history of physics. What seems obvious and fundamental turns out to be approximate, limited, or misleading. Progress comes from questioning what everyone takes for granted. The block universe is, in part, a consequence of taking Einstein seriously. If special relativity is right, and if the relativity of simultaneity is real, then our intuitive picture of time as a flowing river of moments is at best incomplete. The physics suggests something more like a frozen landscape with all moments equally real. This is uncomfortable. It violates deep intuitions and challenges our sense of what time is and how we exist within it. Discomfort is not the same as falsehood, though, and reality is under no obligation to match our expectations. The history of physics teaches us that reality often doesn't match our expectations. The Earth is not the center of the universe. Objects are not solid, but mostly empty space. Time is not absolute, but relative. Over and over, science has shown us that our intuitions, however compelling, can mislead. The block universe might be another such lesson. Our experience of flowing time, vivid and undeniable, might be like the apparent solidity of objects, real as experience, but not reflecting the fundamental nature of reality. Let me share some personal reflections before we move toward closing. When I think about the block universe, I find myself oscillating between different responses. Sometimes it feels liberating. All of time exists and nothing is lost. The moments of joy in my life, past and future, are there in the structure. They're not gone just because I'm not experiencing them right now, but are preserved. Sometimes it feels constraining. If everything is already there, what am I doing? What's the point of effort or decision? This feeling usually passes when I remember that my efforts and decisions are part of the structure and are what makes it be the way it is. The feeling arises, though. Sometimes it feels utterly alien. The idea that I exist as a four-dimensional thread in space-time, that my experience of flow is a pattern in a static structure, that the distinction between past and future is an artifact of perspective. All of this seems so far from how I actually experience life that it's hard to hold on to. Sometimes, rarely, I catch a glimpse of what the view from outside might be like. A sense that everything is there, spread out, complete. A sense that the urgency and momentum of ordinary experience are just one way of being in the world, and that there's another way, the timeless way, where everything just is. These glimpses don't last. I'm too embedded in my temporal experience, too caught up in the flow of moments to sustain the eternal perspective. They're enough to make me suspect that the block universe might be pointing at something real, though. I offer these reflections not as arguments, but as testimony. This is how engaging with these ideas has affected me, and your response might be entirely different. The ideas are there for you to wrestle with yourself. Let me discuss one more aspect of the physics before we close. The Lorentz transformation, which describes how space and time coordinates transform between observers in relative motion, contains the key to relativity of simultaneity. The formula is precise. T equals gamma times the quantity t minus v times x over c squared, where gamma is the Lorentz factor. For two events separated by distance delta x, the difference in simultaneity assignments between frames moving at relative velocity v is approximately v times delta x divided by c squared. This formula is the backbone behind everything we've discussed. It's why moving observers disagree on what is happening now far away, why the Andromeda paradox works out the way it does, why the intuitive picture of a universal present fails. The formula has been tested millions of times in particle accelerators, in satellite navigation systems, in precision experiments of all kinds. It works, and the physics is not in question. What's in question is what it means. And that's where physics meets philosophy, where equations meet interpretation, where the hard work of understanding reality really begins. Let me talk about something I think is often misunderstood: the difference between what physics shows and what physics suggests. Physics shows that simultaneity is relative. Different observers in relative motion assign different times to distant events. This is demonstrated, tested, confirmed. Physics suggests, but does not prove, that this implies the block universe. Mathematical structure of spacetime naturally lends itself to the four-dimensional interpretation. but one can in principle resist this interpretation. One can try to preserve presentism, or the growing block, while accommodating the physics. The debate between these positions is philosophical rather than strictly physical. The physics is the same in all interpretations, and what differs is the metaphysical picture we build around the physics. This is important to understand. When I say the block universe is taken seriously by physicists, I'm not saying it's been proven by experiment. I'm saying it's a natural interpretation of physics that many experts find compelling. It remains an interpretation, though, subject to philosophical debate. Intellectual honesty requires acknowledging this. The block universe is not established fact in the way that relativity of simultaneity is established fact. It's an inference from that fact, and inferences can be questioned. That said, I find the block universe interpretation more compelling than its alternatives. The mathematics of space-time really does seem to describe a four-dimensional structure. The attempts to preserve presentism in the face of relativity seem strained to me. Reasonable people disagree, though, and I don't want to pretend the debate is settled when it isn't. Let me try to summarize what we know and what we don't know. What we know. Special relativity implies that simultaneity is relative to the observer. There is no universal now that all observers share. Events that are simultaneous for one observer may not be simultaneous for another. And the mathematics of relativity describes a four-dimensional space-time rather than a three-dimensional space evolving in time. What we don't know for certain. Whether the relativity of simultaneity implies that past and future are equally real. Whether the block universe is the correct interpretation of the physics. Whether there are alternative interpretations that preserve more of our intuitive picture of time while still accommodating the physics. What we experience. Time as flowing, the present as special, the past as fixed, and the future as open. That, at least, is not a matter of interpretation. That is what we have learned. Let me offer another perspective on what all this means. One way to think about the block universe is that it's humbling. Our usual experience of time, with its urgent present and open future, is parochial, tied to our particular location in space-time, our particular psychological makeup, our particular temporal perspective. The block universe invites us to imagine a grander perspective, one that isn't tied to any particular moment. From this perspective, all of history is spread out, equally real, equally present, and the urgency of now is just an artifact of where we happen to be located. This might seem to diminish the importance of the present. If everything already exists, if the future is just as real as the past, why does now matter? I think this misunderstands the situation, though. The present matters to you because you're here experiencing it. And the fact that the future also exists at other coordinates doesn't make your current experience any less real or any less important. It's like asking why where you are matters, given that other places also exist. Other places do exist, but that doesn't diminish the reality or importance of the place you're in right now. Other times exist too, but that doesn't diminish the reality or importance of the time you're in right now. The block universe doesn't tell you not to care about the present, but just puts the present in a larger context. It shows that your experience of now is one perspective among many, one location in a vast structure. That's humbling, but it doesn't make now less important. Let me explore some of the ways people have responded emotionally to the block universe, because I think understanding these responses is part of understanding the idea itself. For some people, the block universe is deeply disturbing. It seems to suggest that the future is fixed, that we're not really making choices, that we're just puppets acting out a predetermined script. This response often comes with a sense of helplessness or despair. I think this response is based on a misunderstanding, though. The block universe says the future exists, but it doesn't say your choices don't matter or don't influence what happens. Your choices are part of what makes the block be the way it is, and if you choose differently, the block would be different. The block universe is compatible with a strong sense of agency. You make choices, those choices have consequences, and you're responsible for your actions. All of this remains true. What changes is the metaphysical picture of how your choices relate to the structure of reality. Instead of "my choices determine a future that doesn't exist yet," the block universe says my choices are part of a structure that exists timelessly. Both pictures give your choices the same practical importance. The difference is in the background metaphysics rather than in the relevance of what you do. For other people, the block universe is strangely comforting. If all of time exists together, then nothing is truly lost. The happy moments of your life are there in space-time forever. People you've loved and lost are still there at the coordinates of their existence. The past is preserved. This might not help with grief in any practical way, since you can't go back to those moments or see those people again. There's something about knowing they're still there, still part of the structure, that some people find consoling, though. Einstein seemed to find comfort in this view when he wrote to the Besso family. The idea that the distinction between past, present, and future is an illusion might have helped him see death not as an ending, but as a change in location, a transition from one part of the block to another. For still others, the block universe is simply interesting, a fascinating possibility to contemplate without strong emotional charge. It's an intellectual puzzle, a way of seeing the world that challenges assumptions without necessarily threatening anything important. I think all of these responses are legitimate. How you feel about the block universe probably depends on your temperament, your values, your prior beliefs. The idea is rich enough to support multiple emotional reactions. What I don't think is legitimate is refusing to engage with the idea because it's uncomfortable. Reality doesn't care about our comfort, and if the block universe is true, it's true whether we like it or not. Our job is to understand, rather than to pick metaphysics based on what feels nice. Let me discuss one more subtlety: the difference between the block universe and determinism. These two ideas are often conflated, but they're distinct. Determinism says that given the state of the world at one time, the laws of physics uniquely determine the state at all other times. The future is fixed by the past plus the laws. The block universe says that all of time exists together, with the future existing just as the past does. It doesn't say the future is determined by the past, though. It just says the future is there. In principle, you could have a block universe that isn't deterministic. Quantum mechanics, for example, involves genuine randomness, and the outcome of a quantum measurement isn't determined by what came before. The outcome, whatever it is part of the block, though, and exists at its space-time coordinates. Conversely, you could believe in determinism without believing in the block universe. A presentist could believe that the past determines the future even if only the present exists. The future would be fixed in the sense that it's determined by the present state, but it wouldn't exist yet. Determinism and the block universe are logically independent, and accepting one doesn't commit you to the other. In practice, people who believe in the block universe often lean toward determinism, and vice versa, since the ideas have a family resemblance. They're not the same idea, though. This matters because some objections to the block universe are really objections to determinism. If the future already exists, I have no freedom, is really saying, if the future is fixed, I have no freedom. The block universe doesn't say the future is fixed, in the sense of being determined by the past, though. It just says the future exists. Whether you have freedom in the block universe depends on what freedom requires. If freedom requires that the future be genuinely open and genuinely undetermined, then the block universe might conflict with that. If freedom just requires that your choices be causally effective and make a difference to what happens, then the block universe is compatible with freedom. These are deep questions in the philosophy of free will, and I won't try to resolve them here. My point is just that the block universe doesn't automatically settle the question of freedom. There's more work to be done. Let me draw this exploration to a close. We've covered a lot of ground. We started with two people walking past each other on a sidewalk, disagreeing by days about what's happening now in a distant galaxy. We traced the physics of special relativity, the constancy of light speed, and the relativity of simultaneity. We explored the four-dimensional space-time picture developed by Minkowski and extended by Einstein in general relativity. We discussed the block universe interpretation, the idea that past, present, and future are all equally real, that space-time is a four-dimensional structure existing all at once, and that the passage of time is a feature of perspective rather than an objective flow. We explored the arguments for this view, particularly the Reed-Dyke-Putnam argument about what relativity of simultaneity implies. We acknowledged the critiques and alternatives, the ongoing philosophical debate, the unsettled nature of these questions. We discussed the arrow of time and entropy, the nature of change in a static structure, the relationship between experience and physics. We explored what this might mean for free will, for mortality, for how we understand our own lives. Through all of this, one thing has remained constant: the sheer strangeness of time. Whatever the correct metaphysical picture turns out to be, time is not what our everyday experience suggests. The physics has revealed depths and complexities that our intuitions could never have anticipated. Einstein was right about at least this much. The distinction between past, present, and future is not as clear-cut as we thought. Whether it's a persistent illusion, as he suggested, or something more nuanced, the naive picture of time as a flowing river has been complicated beyond recognition. I find this humbling. We walk around feeling like we understand time, feeling like the present is obviously real and the future obviously open. And then the physics tells us that our confidence is misplaced, that the reality is far stranger than we imagined. I also find this exciting, though. These are deep questions about the fundamental nature of reality. We get to engage with them, get to think about them, get to be conscious beings asking what time really is. That's a privilege. Not everyone who has ever lived has had access to these ideas. Not everyone has had the education or the leisure to contemplate the structure of space-time. The fact that we can think about these things, can follow the arguments and glimpse the possibilities, is something to appreciate. Wherever you are right now, whatever moment you're experiencing, you are a point in the structure of space-time, with your consciousness illuminating this particular location in the four-dimensional manifold. The moments before this one are at their coordinates, and the moments after are at theirs. You don't know what comes next. From your perspective, the future is unknown, waiting to be discovered, and you'll experience it moment by moment, just as you're experiencing this moment now. If the block universe is right, though, then, in some sense, the next moment is already there. Your tomorrow already exists. Your next year already exists. And everything that will happen to you is part of the structure. This might be frightening. It might be comforting. It might be neither. It's just the way things are, if the block universe is true. Even if the block universe isn't quite right, even if some alternative interpretation turns out to be better, the physics stands. Simultaneity is relative. The present moment is not universal, and time is not what it seems. That's enough to provoke wonder, enough to make us pause and reconsider our assumptions, enough to remind us that reality is vast and strange and not at all obligated to match our intuitions. I hope this exploration has given you something to think about. These are ideas that reward patient contemplation and don't reveal their full depth on first encounter. They grow richer the more you sit with them. If you found value in this journey, consider subscribing to the channel. There are more explorations like this, more opportunities to engage with deep questions about the nature of reality. We'll continue to learn together, to think together, to wonder together. Thank you for taking this time with me. These ideas deserve careful attention, and I appreciate you giving them that. Tonight, as you go about your evening, as you move from this moment to the next, I invite you to wonder. What is time, really? Is each moment coming into being, or is it already there, waiting for you to arrive? Is the distinction between past and future carved into reality, or is it a feature of your particular perspective? You won't find definitive answers, but the wondering itself is worthwhile. The wondering is part of what it means to be a conscious being in a universe that physics has revealed to be stranger than we ever imagined. Sleep well tonight, and as you drift off, consider. If the block universe is right, then your tomorrow already exists somewhere in space-time. You just haven't gotten there yet. Good night.